So this video is based on the question, will quantum computing signal the end of effective cryptography? Quantum computing is the use of the laws of quantum mechanics to solve computational problems. And this means that we are looking to use quantum mechanics for computing power. This is done by using something called a qubit, which replaces traditional bits. A qubit is capable of both superposition and entanglement. And when these two principles are taken advantage of, a quantum computer is able to do all sorts of fancy math, such as factorizing very quickly. This is done mainly using Shor's algorithm. Most encryption at the moment is done through an encryption system called RSA. RSA is a trapdoor one-way function. This means that while it usually is not possible to decrypt without the private key, the trapdoor information makes inverting the function possible. And the trapdoor information in RSA is based on factorization. Hence the security is so high because factorizing is very time consuming. Because quantum computers are so good at doing this fancy math, this gives us a major problem. However, there are some cryptographic systems that are resistant so far to both normal computers and quantum computers. One example of a system is hash functions. Hash functions can resist Shor's algorithm, and while it is susceptible to another algorithm, Grover's, this is not as fast as Shor's and can be combated by slightly increasing key sizes. While this sounds great for security, there has been a lot of fuss over the past couple of years about security flaws in hash functions, which when exposed pretty much leave the particular algorithm obsolete. One popular attack on hash functions is to find something called a pre-image. This relies on finding some kind of structure in hash outputs, which brings up the issue of true randomness not existing, but that's a completely different argument. For a hash function with a bit length of n, a generic pre-image attack has 2 to the power of n steps. So for a 128-bit output, there are 3.4 times 10 to the power of 38 steps. My opinion on the question is that quantum computing may not mean the end of cryptography due to things like hash functions. However, quantum computing is still in its infancy, meaning that as the technology develops, new ways to break existing cryptography may be discovered. I feel that we should start to worry about quantum computing while developing new forms of cryptography today. To quote Daniel J. Bernstein, cryptologist and professor of mathematics and computer science, to me, hash-based cryptography is a convincing argument for the existence of secure, post-quantum, public key signature systems.